When I say a function is differentiable, what I really mean is that when I zoom in, the function looks like a straight line. This is the graph of the absolute value function. Let's zoom in on the origin. No matter how much I zoom in, this graph doesn't look like a straight line. Consequently, the absolute value function is not differentiable at 0. We can also see this from the limit definition of derivative. So I'm just going to name the absolute value function f for the time being. What I'm trying to calculate is the derivative of f at 0. I want to know, is this function differentiable at 0? Well, by the definition, that derivative is the limit as h approaches 0 of the function at 0 plus h minus the function at 0 over h. Now I can simplify that a bit. The absolute value of 0 plus h is just the absolute value of h, and the absolute value is 0, so I don't even need to subtract 0, and I'm dividing by h. Now what's the limit as h approaches 0 of absolute value h over h? That limit doesn't exist, and consequently, this function's not differentiable at 0. Now, if you're wondering why that limit doesn't exist, well, think back to our two-sided, one-sided limit discussion from before. What's the limit as h approaches 0 from the right-hand side of the absolute value of h over h? It's 1. Well, what's the limit as h approaches 0 from the left-hand side of the absolute value of h over h? It's minus 1. And 1 is not equal to minus 1. Because the one-sided limits disagree, the two-sided limit doesn't exist. And this limit, calculating the derivative, means that this function's not differentiable at 0. Of course, that raises a question, why should you care about differentiable functions at all? Here's some terrible-looking function, but it's differentiable. So if I zoom in on some point, the thing looks like a straight line. Calculus is all about replacing the curved objects that we can't understand with straight lines, which we have some hope of understanding.